This is a video on using differentials to approximate a square root. The question states, use differentials to approximate the square root of 63.96. Well, notice that 63.96 is very close to 64, which has a nice square root of 8. So I'm going to use differentials on the function f of x equals the square root of x. So there's my function. And my x is 64 because that's the easy number to plug in. And 63.96 is 0.04 less than 64. For differentials, I also need to take the derivative. And the derivative of the square root of x is 1 over 2 root x. Now let's look at our differential formula that says that f of x plus delta x is about equal to f of x plus dy, which is equal to f of x plus dy over dx times dx. And if I plug in all my numbers, x is 64, delta x is the same as dx, which is negative 0.04, and I get f of 64 plus negative 0.04 equal f of x, which is 64, plus dy dx, which is f prime, and I evaluate it at 64, times dx, which is negative 0.04. And I work that out. F of 64 is the square root of 64, which is 8. F prime of 64 is 1 over 2 times root 64, or 1 over 2 times 8, or 1/16. And then my dx was negative 0.04. So 1/16 of negative 0.04 is negative 0.0025. So if I take 8 minus 0.0025, I get 7.9975. And that's approximately equal to the square root of 63.96. By the way, if you put it in your calculator, you'll find out that up to 10 decimal places, the square root of 63.96 is 7.997499609. So you'll notice that this approximation is actually good to 1, 2, 3, 4, 5, 6 decimal places. So with very little work, we were able to have a wonderful approximation of a square root. And I'm done with the problem.